This one is I mentioned in the class last time, but the slide is included afterward. So this is a new one. So you did not have your slide set has this. Anyway, iPhone of Apple is assembled in Foxconn of China. Right? And half of the components of iPhone is supplied inside China. It means about half is coming outside of China, or assembled in Foxconn. But Foxconn itself was a Taiwanese world's largest contract electronics manufacturer. Contract electronics manufacturer. Or somebody says, I don't know whether I have a slide for this, but EMS, electronics manufacturing subcontractors, something like that, EMS. But it's the same meaning of contract electronics manufacturer. OEM, do you know OEM? 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 Original equipment manufacturer. Sometimes, say, Foxconn is a kind of OEM manufacturing. The brand is different, not their own brand, right? The brand is to Apple brand, or Foxconn is just manufacturing. Okay? We call this OEM manufacturing style, something. And EMS is specialized for electronics field, electronics industry. This is first time for me to read this kind of wording of contract electronics manufacturer, but it's almost pretty much same meaning of that. Okay, so they don't have their own brand. Probably may have a small components of them, but they are more popular than just manufacturing for their Apple too. So in Korea too, the young generation do not want to work inside a small and medium enterprise. There's a problem, same as Japan. So they want to make a SME of Japan as a high salary, good company. Right? Same as early days of Google or Apple. But now still in China and Korea, SME means they provide manufacturing by low salary. Low labor cost is the main portion of SME. But now they want to move them into high technology SME like a European or United States. Industry 4.0, another picture, big data, cloud computing, CPS, augmented reality or virtual reality, robotics. This is a new technology behind the Industry 4.0. And cyber physical system, there's a three component of them. There's a computation, communication, and control. Or cyber physical system, CPS. And there is another technology called Internet of Things, very popular nowadays. So anything, any object, any physical object has their internet connection. So world of index, world of online, control, and talk each other, and intelligent. Everything. So it's not so special. RFID. What is RFID? What is the meaning? Identification, yes. It's a very special, similar to barcode. Barcode. So every object has a barcode in nowadays, right? Barcode like this one. Nowadays we have a 2D barcode, the complex shape of barcode. But they need a scanner, barcode reader, right? Barcode reader. When you buy something in the supermarket, everything is scanned by barcode, right? And then automatically calculate the money, right? But you can think about RFID as a wireless barcode, Remote radio frequency means wireless. And then IoT is one more step from RFID. So it is connected to internet. So, and also sensor network, wireless sensor network. Sensor network is also connected to this one. Wireless or remote, or that is also related with the IoT technology. So everything has a sensor and also connected to the wireless point. This is another picture coming from Internet of Things. It shows billions of devices. They will connect it in the internet in the future. Say year of say 12 and 16. 16 is here. When this picture is made, I don't know. But see that only internet is PC, but now it's a mouse. What is this? PDA. So and then device is coming. So watch, and then what is this device? This washing machine and traffic signals, and even the toothbrush. And what is this? 50 billions of items are connected into the internet. Then you can control. It's a smart home. Smart home is trying to control home devices using your smartphone, right? So doors, or electricity, or can be, or even toothbrushes. How can we control toothbrushes? And it's another picture of Industry 4.0. So Internet of Things, Internet of Services, and then app store, app platform, app store, material and product, cyber physical CPS, smart factory, and PLM, SCM, CRM, QMS, ERP. This is existing applications. And this is a communication between CPS systems. This is a picture coming from Germany. They are saying this machine is talking each other, including humans. I can work this up by Saturday, switch me off, book up to capacity until Friday, customer order is coming, 50 gearboxes by Monday, magazine is empty, please fill in. Sorry, I cannot work on Sunday. These communications between not only person, but including devices. So how can you make these things are working together? You need the devices, standard. All right? Question?
So how do you
Oh, okay. RFID has two types, passive and active. Passive and active. So active type has a battery inside. So they send signal, broadcast signal. Say my barcode numbers broadcast, or my internet address broadcast. Okay? But passive is you have a scanner. So usually we have a passive type. Scanner devices send the signal. Radar is sending signal and returning back, reading that, right? So in Korea, in highway, we have a high pass boxes. This is the same as RFID, high pass. But high pass device has a battery inside, connected to the car or battery inside. So they send the signals to the device. That's why you can do far away and also faster than negative passive system. QR code. QR code is a two-dimensional barcode, right? QR code. It is, how can I say? This is advancement of barcode is just a one-dimensional array of lines, right? QR is a mixture of 2D images, but the purpose is same. You can include more information inside, more complete, more byte than barcode. All right. Any other questions? And we can go on to second slide for today. So standard for industry 4.0. So German standardization roadmap for industries 4.0. This is a report or book there. And there is also international standards. Many of them. One of them is STEP standard, and we are operating a Korea STEP center. So same picture as CPS, or just automatic devices. Or you can think about robots are talking each other, robots. But robots are coming. This machine comes from Japan. This machine comes from Sweden. This machine comes from USA. Or it can be a robot, specialized robot, right? You can think of it. So how can they communicate with each other? They are saying English, or they are saying Swedish, or they are saying German, or Japanese robots, or special language. So we need a standard language there. So this is a book coming from 2 years ago. Probably they have a new version now. The German standardization roadmap for Industry 4.0. This is a famous picture of Tower of Babel. Is it mentioned inside Bible? Yes? Yes. So they trying to reach to the sky, not sky, heaven, right, by building a high-rise tower. But because of the punishment from the heaven, their language was all different, right, somehow. Right? So they could not talk to each other, so they stopped. They could not finish up their construction. That was the history behind it. Right? So that also shown to many times for meaning of standard or meaning of communication between people and between devices and between things and between robots. So we need a standard. There are three main organizations. We call this is a government organization, international government organization. Means each nation has a membership in ISO, in IEC, and ITU. This is a historical listing. ISO established first, and IEC follows next, and then ITU is the new organization. It's specialized in electrotechnical and also telecommunication. This is for remaining everything, say length, weight, volume, and sizing, and bolt and nut, and machinery, all standard is shipbuilding and aerospace, automotive, all here, machinery. But electrotechnical is a later technology, but has about same size of standard, maybe more than ISO in the future. Now it comes later, new one, telecommunication, it's growing faster. Right? So now the three are about same size, but I don't know, maybe in the future ITU can be bigger. Anyway, these three are international government supported. So Korea is supporting by money and attending people, ISO, also IC. So there is a government office inside Korea to support this organization, standard organization. And inside the European countries, there is a EU standard. Say this is CEN, is European Committee for Standardization, the overall one. This is Committee for Electronics Standards, similar to IEC, but smaller regional. And also there's national organizations too. And this is the same picture, but a little bit different one for automotive industry. Right? Step. You already see this one. Right? And they use different CAD system. So between them, they need to translate or exchange data or this low bearing adapter for steering column and steering pump column. So can you talk each other between CAD system? That is the standard word of step. Data format. And also there is a non-profit consortiums. This is private consortiums. Say that companies pay membership. Sony, Apple, Samsung, they gather to make a standard. One of the well-known is a World Wide Web consortium. They standardize World Wide Web communication protocols, HTTP, something like that. And then X3D is also included. One of them, there are many. One of them. HTTP is the most well-known standard of Web3D consortium, because Web3D is well-known because of the web page, right? HTTP. Right. And hypertext markup, HTML, something like that. There are many more standards coming from, but this is not governmental organization. This is company memberships and membership fees. Monies are coming from. And OPC Foundation is now very popular because of the Industry 4.0 and Smart Factory. And Oasis was also a big one. One of them is Electronic Business XML, right, for the commerce, e-business. And OMG is famous of XML, UML, and then Industrial Internet Consortium is also popular nowadays because of Smart Factory and IoT also. And 3GPP is for mobile standard, broadband. This is for smartphone. LT is Korean Generation 5. LT Generation 5 will be popular in Pyeongchang Winter Olympic. They are saying. Currently they are saying LT3, right? 3 is current version. And also the CDMA, also GSM is also covered. And one M2M. M2M means machine to machine communication and IoT. So this is another new development because of the companies that have a power and money. So they are gathered together to create a standard. because they are saying this national governmental supported organization is too, say, slow to making new standard because technology is faster, coming faster, but this one is very bureaucratical, so that it's slow process. They want to make quicker standard, LTE, something like that. And World Wide Web. And this is for PLM standard. I'm talking in the later stage of classes. So, and there is a step standard, some of them for PLM, and some of Sun Java standard, and .NET from Microsoft, and World Wide Web, W3C, and then W3C is here. So there are XML, SOAP, web services, semantic web, and then is OMG is covering MDA, XMI, ML, and COBA, and PLM service. So they are all collected to create a PLM standard. So it's a very, there are so many standards around the world. Also it's complication, but they need to talk each other. For the small, medium size enterprise, Microsoft, Apple, they are big companies. They can lead standards. They can make their way to make, say, something like a Windows Explorer or iPhone OS, Android of Google. So there is company standard, right? Company format. But that is popular in the world. So they create standard around the world without any governmental support. And sometimes government can enforce standard, something like a millimeter, 1 meter or 10 centimeter, measuring or weight measuring, length measuring, or other things. In old days are supported by ISO, is especially in this way. But small companies, something like a Java Max, they cannot read, they cannot enforce like a big company or government. But they need to conform and compatible to standard to penetrate market or survive. They need to survive. Right? They need to follow the standard. That's why many are related with standard. Question? And there is also different ways of seeing standardization. One is how to make one software is working everywhere. Say this one. This one is not a data. This is a software. Explorer is an operation program, right? So in the world, if you have all people is using single software, we don't need any standard for data format. Right? But this is not working. It was somehow worked for several years, but it comes with other competitions. Safari, so that you need HTML for special for Safari and special for Explorer. There are sometimes one website is not working in Apple, sometimes it's not working for Microsoft. That's why we need to have a standard format of data, right? According to ISO. But sometimes they don't want to follow the ISO standard. Microsoft or Apple, they create their own format, variation, their own version. Right? That creates problems. So it is sometimes a competition between, or power game between big companies, between governmental offices, between users. And also, if you have a software like Explorer is working for everybody, small people, like individuals, they just follow MS leadership. But sometimes big companies like military organization or governmental office or Samsung or Hyundai, they has their own version of Explorer for their own need. So there is also comes with a variation of software. Not only data, but also software has a variations. That creates problems of communication between them. Apple version of Safari version of HTML, Safari version of Explorer, that create problem. Also, Hyundai version of Explorer and government version of Explorer, that creates variation. So it's kind of power game and political trouble, and so we need to have a way to make standardized working. Otherwise, Industry 4.0 or smart factory cannot do that. Because the Internet of Things, right? Everything want to be connected to internet and talk to each other. But how can we do that? Is Babel Tower story coming again? So we should find out how can we do that. So this is coming from Industry 4.0. So full life cycle in industrial manufacturing. Sources from Germany, Fraunhofer for Industry 4.0. So this is order is following this way, including customer relationship management and enterprise resource planning. And product is coming in this way, computer-aided design, computer-aided engineering, supply chain management, product data management. And factory working is in this way. And CAE technology and simulation analysis is going. And then comes with a factory floor plan, manufacturing execution system. Now go to the operation and maintenance, after service, customer relationship management again, quality management system, and life cycle management. So then we need to talk, these systems should be talk each other to make a production working. Industry of smart factory. How can we make from a standard way? There is a need for standardization. You understand this? And then how can you make the standard? So this is a final stage of development, product and service and application practice. This is a standard for Germany, organizational standard, European nation, EU standard, international standard, and commercial consortium, industrial consortium standard, and Korean standard, national standard. So because of the laws and regulation, technology advancement, research project, there is a need for standardization. And then there is a committees of national adoption, in European regional adoption, international adoption, and also company adoption, consortiums. And we need to have a consensus. So balloting in ISO. For the smart factory or Industry 4.0, there is a special IEC. IEC is Electro Technology Committee, or similar to ISO. There is working group of technical committees. Many technical committees under IEC organization. One of them is 65. Title is Industrial Process Measurement, Control and Automation. And this technical committee has a subcommittees. Subcommittee A, B, C, E. They are working on system aspect, measurement and control device, industrial network, devices and integration in enterprise system. There are so many organizational hierarchy there. Under ISO Technical Committee 184, that is for automation system and integration. And there is subcommittee 1245, physical device control, numerical control machines, robots and robot devices, and there is a data. This is community for subcommittee for step standard N plus more. And there is also subcommittee 5 is for interoperability, integration, architecture for enterprise system and automation applications. This is committee for floor devices. The factory floor, there are so many machines, right? And the machines need to talk to each other. Same previous slide of cyber physical system of Germany. The machines want to talk to each other. There's a protocol coming from, standard protocol coming from this company. It's designed for data, only data. And another organization. This is a joint technical committee. Joint technical committee between ISO and IC. They two organizations, big organizations, have a joint technical committee. Number one is for information technology, IT. There are so many working group and subcommittees. One of them is Internet of Things. One of them is information exchange. One of them is computer graphics. And one of them is interconnection. So X3D is done in here, X3D. Together with W3C. W3C and ISO JTC1 is X3D. Interconnection of equipment and IT security and JPEG. JPEG is coming from this organization. JPEG, motion picture, standard. MPEG and JPEG, MPEG. RFID is coming from here. RFID, yeah. RFID is for automatic identification, data management interchange, and other stuff. So it's complicated things. And Korea Step Center. It's Korean. COSD, TC1 is for meetings, and journals, and step meetings, dictionary, and introduction. And last, what was that? Last Thursday? Friday. I have been to Seoul. There is a small workshop on Industry 4.0. And one of the speakers is, there is one more line here, but it's not shown in this in projector. The lady from Karlsruhe University of Germany, and she's a director of Institute of Technological Information, and she explains about Industry 4.0. And you see the similar slide as I showed before. This is Karlsruhe Institute of Technology. Innovation. Okay.
Okay, so now I'll read some questions. So we have mentioned a lot about the Industry 4.0. So actually, the Industry 4.0 brings a lot of like potentials and advantages and disadvantages. So, what do you think about the main disadvantages of this the Industry 4.0? What's a big barrier for Industry 4.0? Okay.
I think one of the main problems or barriers is people agreement, because Industry 4.0 might replace some jobs. So it's talking about automation and treating people like machines, basically, and how we interact with other machines. So replacing the existing jobs might be a barrier to accept Industry 4.0, but in business, power always influences these decisions.
So the first barrier is jobs. So what else?
Like indoor server, and then one of the cloud Amazon, for example, they made, I think, a server for the CRK. And
CRK?
one of the Amazon people was working like collaboratively between Amazon and CIA. So we made it inside, basically. And that's one way, but maybe there's others.
Okay. Yeah, for the smart factory, so for usually for the common, the very ordinary factories, they have a lot of warehouses and even the logistics. So if the industry 4.0 really comes, so I guess a lot of like warehouses and even the logistics will be totally reduced. And even just you have mentioned, a lot of workers and we lost their jobs. And even for a lot of products, so how there will be a lot of data. So how can we manage those data in terms of like those a lot of like materials, raw materials, and even the media materials, and even the final products.
Sorry, can you repeat the question?
Yeah. So okay. So yeah, in terms of this Industry 4.0, so what do you think about the advantages of Industry 4.0? Advantages, like the potential of this technology.
Good side.
Yeah, good side. So in the future, the factory will become very smart. So, so how can it become very smart? And if becomes very smart, so how can we manage it, the process, to make sure that this process can be very like efficient and very secure?
It's a very open-ended question. I guess that's what many researchers are trying to find out. Yeah. It's hard to just answer in 2 minutes. But yeah, I mean, it must have some advantages in terms of money, obviously. Otherwise, businesses would not be funded and the government wouldn't pay. So, yeah, I mean, on one side, it's costing people some jobs, and on the other side, I think it might also create other types of jobs. Like with, let's say, with 100 people, instead of running one factory, you can run 10 factories. So this kind of also adds to the growth factor, so the economy can grow a lot more. So I think it has economic impact, but maybe in the long term. In the short term, it will cost people some jobs.
Yeah. But I think if the Industry 4.0 if it's really comes, so finally the total number of the factories, I think will be decreased, because we don't need to because it's smart, so we don't need to go to the factories to work, and we can manage it in our home even. Because now it's information society, so we can do it in our home. So why should we go to the factory to do that?
So it depends on how you define a factory. If you define
Yeah, let's just like so for example, for the 3D printing, many people think that 3D printing really brings a lot of profits, but there are also a lot of limitations. Like for sometimes if you want to print something, maybe the accuracy or even the size of the total the real product. So maybe for this process, there will be a lot of disadvantages. So can we say that smart 3D printing can be a good representation for the Industry 4.0?
So I think it's kind of a process in terms of you mentioned the 3D. now it's development, right? So I think the technology will become more advanced. So I think it maybe should be the conclusion.
Okay.
3D printing is just one section of Industry 4.0.
Yeah.
Because it's like the mass customization component, let's say, of Industry 4.0, but you still have the communication. Like if you need mass production, maybe 3D printing is not the ideal way to do it.
Yeah.
You can still use traditional methods, but with more IT involved. You don't have to totally change your method to 3D printing if it's not the most economical option to do that. So yeah, I don't see factories disappearing anytime soon, but maybe they will. I don't know.
Okay. Actually, I've thought too much about the Industry 4.0. So, what types of problems does this information technology really want to try to solve? Is it like just make the factory become smart? Just like
I think for the business, the biggest motive would be money, if they can save cost and make the same product with lower cost. So that's better for them. If they can make the mass customization. Am I speaking too much? If they can do mass customization, that's also useful if they can satisfy them.
okay. Okay. So, which kind of problems does Industry 4.0 really want to solve? Is it briefly just using some data management technology to make the factory become smart? Yeah, because there are a lot of standards for data exchange, so it will become a very big data cloud. So we have to, it will become very complex and complicated. So sometimes I think it will, on the other hand, make the process of production become quite very intricate. So how do you think about it?
First is reduction of time to market and reduction of manufacturing cost and finally customization. I think.
Okay.
I have wrong.
So, what do you think about the current trend, the developed trend of the Industry 4.0? So nowadays, the deep learning and VR and even AR, they become quite popular. So, can you imagine more like a development tendency or even a trend for this process?
I think it's developing. In our department, there's a function industrial engineering department. So some people work a lot on simulating factories and treating how to simulate workers and machines and machine failures, and some machine failures have to still satisfy the orders. So they try to simulate a few days ahead and see whatever plan they're making is good enough. So I guess that's one part of the development. And yeah, from all the technological points of view, you have to develop the technology first and then the application for it. I'm not an expert, so I cannot
Okay. Yeah. So, what do you think about the main characteristics of Industry 4.0? Yeah.
Main paper.
Yeah.
I think it's customization.
Customization.
Customization means customer is also manufacturer and designer.
How about the process of production?
Customer find PRM database and find some design of part and assembly, then offer some system and factory manufacture customers product.
What? So, Donguk, how do you think about it? Donguk. Mm-hmm.
Is important because one company cannot cover all of these plans. I think the main thing is to improve intercooperation between companies.
Yeah. Okay, I know you are doing like a product data management, like, about this kind of research. So, in this process, so what's the most important thing you have to pay attention to in order to make this process totally like make it related to the data management to some extent. Like the data management is quite important, and so you are doing some research about the data exchange between the different companies. So it's kind of like a product production management. So in this process, what's the most important characteristics of data exchange in your research? Like, what have you learned from this process?
You have an answer or?
Yeah, I have question just okay, yeah.
Because of time, we can stop around this. Thank you very much for your discussion. Because it's the first time we tried,
Yeah.
and I know it's now very difficult to lead this discussion. As time goes on and other people join,
Okay.
we will improve, I hope.
Okay.
Thank you very much. And I hope you can make a summary of this discussion session.
Okay. No problem.
Okay.
Okay.
Thank you very much.
Thank you.